This is the second part of the Activity 3.1 video series. If you recall, in Activity 3.1, we had the scenario where we hire our neighbor's son and we pay 2 cents a day. We thought it was a good idea to hire him, and it turns out it was a disaster because by July 31st, I think we'd have to pay over $2 million for a day's worth of service. We answered problems 1 through 7, I believe, 1 through 7A. And now we're asked to sketch a scatter plot of our table. So listen, we can plot the points by hand, but this is a good opportunity to use the scatter plot function of our calculator. So I'm going to open up my calculator, and I'm going to press the STAT key. I press enter. And now I have some stuff in here from a previous calculation, so I'm going to clear this by pressing the clear and enter. And then again, I highlight L1, I press clear, I press enter. So now I can enter my data. Now from the first page, or page 197, we had our table. So I'm going to enter my L1 with the inputs. So that's 1 through 8. So I press 1. And let's just make sure I've done that correctly. And actually, I want to go back to the problem. I have a feeling the problem went up to 10. So let's just take a look. Yeah, July 1st to July 10th. So I have to add a few more. Looks like 2 more items, right? So we have 9 and we have 10. And then my L2 would be the pennies that we pay. Okay, and now if I want to do a scatter plot, well, if I go to my y equals, I want to clear this, and then I want to highlight my plots. So my plots are on, I press enter. And now when I press the zoom key, number 9 says zoom stat. There's my scatter plot. Okay, so if I were to graph these points as ordered pairs, 1, 2, 2, 4, and so on, this is what my graph would look like. All right, so there's no need to actually copy that into this section of your book, right? And I guess it's good to note that the x-axis is days and the y-axis is the days pay, right? So I kind of typed those labels on my graph here. So now I scroll down, they give us a little explanation here. They say that graph looks like an exponential function, right? And we know it's not linear, right? A linear function would be a straight line, and the exponential function has a curve to it. And then they give us a little definition. They say some exponential functions could be of the form y equals b raised to the x, where b is the base, and it's a positive number not equal to 1. Right, so b can be greater than 0, b cannot be equal to 1. I took this a step further and actually wrote the general definition or equation or form of an exponential function. Y equals a times b to the x, where a is typically your initial value or your vertical intercept, and b could be a growth or decay factor. Okay, it depends. Right? B is a growth factor if b is greater than 1. So if the value of b is greater than 1, it's a growth factor. It's considered a decay factor if b is between 0 and 1, right? So any fraction, right, if b was a half, that would be between 0 and 1, or some type of positive decimal, less than 1 would qualify as well. So if b is between 0 and 1, we have decay. If b is bigger than 1, we have growth. And this is the general form of our exponential functions. Okay, so now they say, okay, why don't we try to graph the problem that we've just done, right? This p of n equals 2 to the n. I'm going to replace p with y and n with x. So we're going to actually graph y equals 2 to the x on our calculator. So I press y equals. I turn off my stat plot. We no longer need the scatter plot. I press enter. So now my plots are off. And I'm going to type in 2 raised to the x. So I press the caret key and then the x. And they give us a window. They say, let's use the window -10 to 10 and -2 to 10. So I press the window key. And for the negative, you have to make sure that you use the key below the number 3, not the subtraction sign. So here's the negative key. And then we go to 10. Okay, so I think this is the window they gave us. X min and X max, Y min and Y max. I press graph. And here is my function. Okay, now let's see what they ask. All right, so it says use your calculator to sketch the graph. We've done that. Then it says because the graph is continuous, it has no holes, what appears to be the domain of the function? All right, so think about that. The domain is really any of the x values that are acceptable. So this graph goes down and to the left, basically to -infinity, and it goes up and to the right to +infinity. So really, x can be any value. Okay, so I would say the domain is all real numbers, right? The domain is what happens along the horizontal axis. So I put domain is all real numbers. Then for the range, remember that's the greatest and the smallest number for y. Well, it looks like y goes up to +infinity, but it never really gets below this y-axis, right? I'm sorry, the horizontal axis, right? It never goes below 0. So my range would be from 0 all the way up to infinity, or simply just y is greater than 0. Okay. Then it says determine the y-intercept by substituting in 0 for x and solving. Well, think about it. If I put in 0 for x, anything raised to the 0 is 1. All right, and we can do it on our calculator. All right, if I were to press the trace key and press the number 0, it's saying, okay, when x is 0, y is, press enter, y is 1. So 0, 1 is our y-intercept. And then it says, is the function increasing or decreasing? We can definitely say it's increasing. Whoops. Because as we go from left to right, we're going up a hill, right? Think about having a man or a woman where my arrow is. And if I'm walking to the right, am I going up or down a hill? If I'm going up a hill, the function's increasing. Okay, so we'll stop here, and then we'll continue a third part momentarily. Thank you.